Hi, Pre-Calculus. Here are your 1.4b rational expressions notes. So the last couple days in class we've been simplifying. You start out with some sort of rational expression. Remember, that's a polynomial in the numerator and a polynomial in the denominator. And the first step we need to do here is to factor. Factoring will pretty much always be your first step, so get used to it. So we factor the numerator and the denominator of all of the fractions. And then after we factor, we're going to reduce. So if I have an x minus 1 on top and on bottom, I cancel it out. Same with the x plus 4. And you just cancel 1 for 1. So x plus 4 on top reduces with only one of the x plus 4s on bottom. And then you rewrite. So the standard notation is to pull out the 3 and put in the front, any whole numbers. And then usually you go from greatest to least in terms if we had more parentheses here, we would order them. You don't have to do it, but it just looks nicer. So the 3 would come out in first. I have an x plus 3 left on top, and then I have an x plus 4 in the denominator. So this will be my final answer. Now, on a test or a quiz, you can double check your work by using your graphing calculator. This is a pretty quick way to check. So you plug in the original problem, taking care to tell the calculator the numerator and denominator of the fractions, and grouping the fractions with parentheses. This will take just a little bit of getting used to, so if you practice it on your homework, it'll help for tests and quizzes. And then you also, in your Y2, plug in your answer, your final solution. Now, if these two things really are equal, their tables will be identical. So notice we're getting identical values in the table. The only thing here is that we're getting an error at 1 for the original problem and no error at 1 for our answer. So let's look and see why that happens. You'll notice that in the original problem we have an x minus 1 in the denominator, and so obviously we can't plug 1 in. 1 is not a part of this domain. However, since the x minus 1's reduce, there's no x minus 1 in the denominator of the final answer, and so that's why there's a discrepancy between the two table values. Dividing rational expressions is pretty simple. We're again going to start with factoring. So I'm going to factor everything that I can. And then dividing fractions is easy as pie. Flip the second and multiply is a silly little rhyme that can help you remember what to do next. Really, you're just multiplying by the reciprocal. So once I get this factored, I'm going to flip it upside down, the second fraction, and I'm going to change the division sign to multiplication. After I do that, then it's just the same steps as multiplying rational expressions. I'm going to reduce anything out that occurs both in the numerator and denominator, and then rewrite my final answer. Okay, and again, I could check this on my graphing calculator if I wanted to. I could also check it just by picking a number like 5 for x, plugging in 5 everywhere I see the x's, and then doing the same thing. And I should get the same answer on my calculator for both the original problem and my final reduced answer or simplified answer. So that's another way to do it if you don't want to plug it into your y equals. Adding and subtracting fractions, it turns out, is a little bit trickier, and you guys already know this from years of experience of adding and subtracting fractions. The first step is still to factor. So when you see an addition or subtraction problem, you're going to want to factor everything, especially in the denominator. And then we're going to need to find a least common denominator. So when I factored this original problem, x squared minus 1, I got a difference of squares, x minus 1 times x plus 1. And here, something squared I just wrote out as its two factors. So that what you see in orange, or maybe it's orange, on this problem is the original. And then to get the LCD, I multiplied the fraction on the left by x plus 1 on top and on bottom because I need these 3 factors on the bottom of both fractions. And then I also multiplied by x minus 1 on top and bottom. Now notice, since this was a subtraction sign, to save myself a little bit, I turned it into a plus a negative 2 because I'm going to have to remember to multiply negative 2 in, or distribute it into this x minus 1. And when I do that, a negative 2 times x gives me a negative 2x. Negative 2 times negative 1 gives me a positive 2. You have to be really careful there and make sure you distribute the negative into both terms in this binomial. And then after I've simplified the numerators, you have to really resist the urge to cancel here. I know that I see an x plus 1 on top and an x plus 1 on bottom, and it's going to be so tempting to just cancel those out. The reason you see it, though, is because you put it there. You actually put the x plus 1 on top. And so you have to resist the urge to cancel, and instead, after you get a common denominator, you're going to combine like terms. So x plus a negative 2x is negative x, 1 plus 2 is 3. On addition subtraction problems, you really don't reduce. You don't cancel. Notice nowhere in this problem am I canceling anything out. In fact, if you are canceling something, you're probably in an addition and subtraction problem doing something wrong. So be very, very careful on these. If you see a minus or a plus between fractions, you're not probably going to be canceling. Now, complex fractions are just bigger, uglier versions of the same thing. So for instance, if I start with this original complex fraction, and it's complex because it's got fractions instead of fractions on top of fractions next to other fractions. I think last year we joked that this was kind of like fraction inception. The first thing you're going to want to do is simplify the numerator and denominator. So I would be looking at this numerator of my overall big fraction, here's my big division bar, and this denominator. And I want to simplify those like the other part doesn't exist. So sometimes I even take my fingers and cover it up and think, okay, how do I simplify just the top half of this big rational expression? Now to do this, I'm obviously going to need to get a common denominator. So I multiply by y on top and on bottom, and I end up with x plus y over y. So the numerator is simplified now. And then I need to do the same thing for the denominator. So obviously here I'm going to need to get a common denominator, so I multiply top and bottom by x. When I put these together, I get x minus y all over the common denominator x. Okay. After you simplify the top half and the bottom half of the fraction, you're going to flip the bottom and multiply. So I take this bottom fraction, I flip it upside down, and I change it to multiplication. And then from here, if you could reduce, you should. But if you can't reduce, it's important that you don't. So I'm going to rewrite this. Any plain variables, I'm going to put out in front single terms, or sorry, single factors. And then binomials come next. Trinomials would come next if you had them. So this is my rewritten answer. Now, let's say you were tempted to cross things out. You're like, oh, I think I can probably go one step farther and cross this out, and you could do something, I don't know what you would do. Maybe you'd throw a negative in there to make it okay or something. Any problem that's this complicated, that starts out as a complex fraction and ends up something that you're unsure of, and it's just x's and y's everywhere, and you don't really know if you got it right or not. On a test or a quiz, choosing a number for x and a number for y is going to be a really good way to check your work. So let's say up here I make x equal 2 and y equal 3. Okay. You don't even have to check your work on your paper necessarily. You can check it on your calculator. So if I make x equal 2 and y equal 3, I would have 2 divided by 3 plus 1. There's the numerator of my fraction. And 1 minus 3 divided by 2. There's my denominator. And now I want to take my numerator, so 1.66666 divided by my denominator, negative 0.5. And I get a decimal here, which I think I can probably use mathfrak. Oh, I didn't quite put enough sixes in there, so 1.666. I'm going to go ahead and turn that to mathfrak before I divide it by negative 0.5. Oh, son of a gun. This is terrible. Sorry, this is me not doing a very good job. Let's go ahead and try this one more time. 2 divided by 3 plus 1, hit enter, mathfrak. I know that's going to be a fraction. And then the other one came out, the denominator came out, I think, to negative 0.5. So I'm going to divide that by negative 0.5. The trick here is I just want to get, gosh, that is really being stubborn. I don't know why. Anyway, the negative 3.33 is my answer here. So this first fraction was negative 3.33. Okay. And then I go down to my answer. So x is 2. So 2 times 2 plus 3. And then I want to divide that by 3 times 2 minus 3. And notice I get the same answer both in the beginning and in the end. So that would check, and I would know that I was done and that it was correct. Man, that took a while to get there. Sorry about that, guys. In any case, we're going to keep working on this a little bit more on Monday, and there will probably be new notes on these rational expressions on Monday also. But for now, have a good weekend, and I will see you later. Thanks.